Okay, I'm going to say a bunch of stuff here. Page 92. Maybe I can clear up some of what's going on. So they asked 44 kids. See, right there, N is 44. It tells you how many there are. Sometimes they call this a mini tab. It gives you all of our data. 5-number summary, the mean, standard deviation, all that stuff. Very nice. Now, let's see. So, we can't forget our socks, right? Shape, outlier, center, spread. That's how we would describe this. And what do we have? So the shape, it's kind of bimodal, I guess you would say. It's got 2 peaks here. Looks like it's skewed, right? We've got some bigger numbers out here. Skewed to the right, which indicates that the mean will be larger than the median, which is true, right? Skewed data is going to pull that median out further. See, these bigger numbers are going to give you a bigger average versus the middle number will stay relatively the same. And we've got Q1, which is the 25th percentile, right? 25% of the data is less than 11. And Q3, which is the 75th percentile, 75% of the data is less than 17. Okay, there we go. And we can look at the spread, which is kind of between the Q1 and Q3, or the interquartile range, can give us the spread, or we can look at the range like that. Okay, there's that. Now, what they do is they say, well, how far were these kids off? Their error. So the room was actually 13 meters, okay? 13 meters. So if we subtract 13 from every one of these data points, it tells you what their error was. How far were they off? So, like this kid was off by 3, okay? This guy was off by a negative number, okay, in the other direction. Still off by, what, 5, negative 5. So, that's what they do. Subtract 13 from all of these. Now, what does that end up doing to our dot plot? Does it look the same, or is it going to look different, and in what way? So what we do is we take 13 away from all of the numbers. And they're nice because they show you right here. Here's the original numbers, right? And this is after you subtract 13 from everything, right? Take 13 away from the average. Take 13 away from each one of those numbers. So it's basically going to take the exact same graph, here's our original, and just kind of slide it down, okay, by 13. The shape doesn't really change, okay? It's still spread in the same amount. So in other words, the interquartile range won't change, right? The range isn't going to change. The difference between these two numbers is the same, even though they're smaller. And then also the the standard deviation doesn't change either. It doesn't stretch this thing, it just slides it down. Same exact shape, just smaller. Okay, so let's take a look at what that looks like. Well, I guess it's that tan box helps us. So this might be good to write down in your notes. Maybe I would let you use it on a test or a quiz. Plus, it just helps you remember it when you write it down. Basically what we're saying is if we add or subtract a number, that's A, right? Well, what gets changed? The median, the mean, the quartiles, the percentiles, all that stuff gets changed, okay? So if we add, say, 20 to all the numbers, all of those get 20 added to them. If we subtract 13, all of those go down by 13. But what does not change? Well, what doesn't change is the shape of the graph, which means the range, the interquartile range, and the standard deviation will not be affected because we're not stretching it or shrinking it. We're just sliding it in one direction or the other. Okay, hopefully that helps. Let's talk about when we multiply. So in this one, they took that second graph, the one where they subtracted 13 from all of them. So this is their error in meters. And they said, well, what if we just translate it into feet? Well, it turns out there's about 3.28 feet is equal to 1 meter. So what they had to do is take each of these numbers and multiply it by 3.28. So the minimum, -5, multiply it by 3.28. That's where that -16.4 comes in. Okay? So all of those numbers get multiplied. And you'll notice the result. It gets spread out. Aha, so what does that mean? Okay, so everything gets multiplied by that 3.28. It stretches it. The bigger numbers get bigger, the smaller numbers get smaller, and it stretches it out. If we were to divide by a number, it would make it narrower. Okay, but let's just talk about stretching this thing out. What does that mean? Well, that means that everything gets multiplied by 3.28. Even the standard deviation, the interquartile range, everything gets multiplied by 3.28 when you multiply by a constant. The only thing that doesn't change is the shape of the graph. It's still skewed to the right, still has these two peaks like this. It's still the same general shape, right? The shape is the same, it's just spread out, okay? So, now let's take a look at what that box says. Let's see, right? Down here again. Multiplying or dividing by some number b, right? A positive or negative or zero. It multiplies everything. Measures of center, mean, median, quartiles, percentiles. Everything gets multiplied by that number. Multiply measures of spread as well, okay? Everything gets multiplied. Range, interquartile range, standard deviation, everything gets multiplied by that number. And what doesn't change? The shape of the distribution. Okay, hopefully that helps. I don't know, I'm not sure if I went too long in this video, but there we go. And we will, let's see, talk about that stuff tomorrow.